Hello everyone, so welcome to the next video. In this video, we will talk a little bit more about the nomenclature for the alkanes. This time, we want to talk a little bit about the examples which have a little different structure when it comes to the substituents. Okay, so this time, let's take a look at this molecule. So when I see this molecule, I notice that again, you go by the same rules. You look for the longest chain. The longest chain here seems to be the one which is the straight chain. Okay, so we have 1, 2, 3, 4, 5, 6, and 7 carbons here. So seven carbons here. 1, 2, 3, 4, 5, 6, and 7. Okay, so that's an heptane. We get that part. That's an heptane. The point is, what is this guy? So this is your substituent, right? But what is the substituent? We have seen methyl, we have seen ethyl. This has 3 carbons. So you might want to call this propyl, but the thing is, it's not a propyl as in, let me quickly draw what a propyl might look like. So if I had, something like this, you see, this is a straight propyl. I've got, this is my main chain in the bottom, 1, 2, 3, 4, 5, 6, 7, the heptane. And then for the substituent, I have 1, 2, and 3 carbons, right? That's a simple propyl. But this one is different. Okay, this one, the attachment is different. It is 3 carbons, but the thing is that this guy has been attached with the central carbon, not the first carbon, but the central carbon of the propyl. Okay, so guys, what we need to know here is that whenever we are naming, there are 2 names, guys. Earlier, people used to name different organic compounds, and before, the scientific community sat together and made generalized rules for global use, we had names which were called common names. Okay, which, like, you can say the scientific community knew those names, and but there was no general order in them, so there was no like rule to follow. You just memorize that name, right? But later on, the IUPAC naming came in, and that's the nomenclature we follow today. Okay, the IUPAC nomenclature. So all this numbering you're doing, all the nomenclature we learned in the previous videos, that's all IUPAC nomenclature. Okay, now what happens here? We got a common name for these and IUPAC name. But the thing here, only for these substituents, okay? The common names are so common even today that nobody uses IUPAC, but still we want to learn both. For the substituents, we want to learn the IUPAC name as well as the common name, okay? And there are only 4 of them that we need to remember, okay, for this class. Okay, so the idea is that you got the heptane, which is the 7 carbons. So this is heptane, right? But then on the heptane, you got the substituent. The substituent has 3 carbons. We need to look at these substituents a little differently. Okay, the thing is, we will ignore the remaining portion of the main chain. We'll just look at this substituent for right now, okay? And as I said, we'll have 4 examples to discuss. So we have, for example, a substituent like this. I'm just cutting off the remaining portion, the parent chain. We're just looking at the substituent right now. So guys, what I'm looking at is 3 carbons, right? So the common name for this is isopropyl. Okay, that's just memorization in the sense that, okay, you got 3 carbons, so it must be propyl, and it's iso. Iso means same in science, in chemistry. Iso means same. Why is it same? Because when you look at this branching carbon, you see this carbon. This is the carbon of the substituent, right? Again, just to make sure you guys understand this, imagine there is the main chain going around here. Okay, we're not even worried about that. We are ignoring that. The parent chain is being ignored. This is the substituent, okay? So this carbon, the carbon of the substituent where the branching is happening in the substituent, this carbon has same neighbors. So iso neighbors, same neighbors, okay? So isopropyl, okay? All right, now, what do we have next? The isopropyl is the common name. This is the common name. We also need to know how do we name them with IUPAC nomenclature, okay? Now, how does that work? For that, what you need to do is this. Your connecting carbon for IUPAC nomenclature for the substituent, guys, this is for the substituent. What rule you need to remember for this, guys? The rule is that your connecting carbon, the connecting carbon gets number 1. So you label that number 1. So label your connecting carbon number 1, and then look for the longest chain. In the substituent, look for longest chain in the substituent, okay? So the first thing is connecting carbon, label it number 1. Second rule, look for the longest chain from there. So longest chain for this carbon is either go this way and call this 2. You could have also gone the other way and call it 2. So you basically just have 2 carbons in the long chain, right? Now, and then name that, okay? So you have 2 carbons here in the longest chain, right? It has to be continuous. So you cannot do 1, 2, and then 3 here. That's not continuous. So 1 and 2, okay? 1 and 2 is ethyl, okay? So that's ethyl right here. Now, what do we now? Why do we not call it ethane again? Because we're still working with a substituent, okay? We're not dealing with the parent chain. So still call them, end them with YL. This is still alkyl. So ethyl for 2 carbons. And then I have 1 carbon. This 1 carbon is, think of this as a substituent of a substituent, right? So this carbon here is methyl. So this is methyl ethyl. Again, where is this methyl sitting on the parent chain of the substituent? It's sitting on number 1. So it's 1-methyl ethyl. So guys, this is the IUPAC name of this substituent. Okay, now this substituent was pretty straightforward. This one you didn't need anything. This one you just call propyl. There's no need to number nothing because it's a straight 3 carbons. Here, I have 3 carbons, but they're not straight, they're branched. That's when this complication comes in, and you need to know the rules for naming them, okay? So guys, isopropyl is totally okay to use, okay? And 1-methyl ethyl is also okay to use. You should know how to name both of them. And as I said before, this is one of the 4 common names you need to know. We will do the other 3 right now, okay? So let's take a look at that. The other ones, guys, all 3 of them, they have 4 carbons, okay? This one you saw has 3 carbons, so that's only one possibility. So see, 3 carbons, propyl and isopropyl, those are 2 possibilities for substituents. Now we're gonna go and look at butyl. Butyl will have 3 options, okay? So as I said, butyl has 3 different formations possible. So guys, of course, 4 different possible. So one is where you have, your longest, your substituent just happens to have 4 carbon, right? So that we just call butyl, sometimes also called N-butyl, and just suggests that it's straight chain. So 1, 2, 3, 4 carbons. So that's one option. That's a pretty straightforward one. So you can just call it butyl or N-butyl, does not make any difference, okay? Now let's see the next option. Okay, the next option is where you have 4 carbons in your substituent. Okay, again, we're ignoring the parent chain. Okay, here the connection point is the 2nd carbon of the butyl. You see here in butyl 1, 2, 3, 4 carbons. This time, the 2nd carbon is the attachment point. Okay, in this case, you have to name this differently. Okay, so what are the other options? So let's look at all the options for right now. Okay, the next option is Again, you have the parent chain not shown. Okay, so again, I have 1, 2, 3, 4 carbons, but again, the attachment is different here. Okay, then you have this option. Okay, so in all the cases, we have total 4 carbons. 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, and 1, 2, 3, 4. But every time the longest chain is different. Okay, so again, how for the IUPAC name, how do we number them? We number them from where the branch point begins. Okay, so the connection point is where we begin. The connection point will get the 1. So this gets 1, this gets 2, this gets 3. Again, why didn't we go to the left? Because that will just give me 1 and 2. That will be only 2 carbon long. If I go right, I get 3 carbon long. So that's the side you pick. For this one, you see, this is the connection point, and you get 1, 2, and 3. Okay. In this case, this is the connection point, and you put the 1 here. 2 could be this on the right or on the top or on the left. They're all same. Okay. Now, so we got 4 options here. So we got the butyl just like that. Then we got this option. What is this one? What does this one look like? So this one here has 3 carbons. 3 carbons is called propyl, right? And the propyl has this metal sitting on it on number 1. So this is 1 methyl propyl. So this is very simple. 1 methyl propyl. This is, of course, saying different from 1 methyl ethyl, which was the isopropyl we learned. So this here, instead, this is 1 methyl propyl. Okay. Now, what is next? The next is where we look at this one. So look at this one. This one again has 3 carbons. So this one is also propyl. This one is propyl, but this time this methyl substituent is sitting on number 2. So this time this is 2 methyl propyl. Okay, so I hope this makes sense. So we have the propyl, but the second carbon has the metal. Okay, right. Now what is next? The next is this last one. This one, you have 2 carbons in the longest chain, so this should be called ethyl, right? So this is ethyl, but this time I have 2 substituents. Both of these substituents are methyl. Remember when you have 2 metals, what do you call that? You call that dimethyl. And both of those metals are sitting on 1, so this would be called 1,1 dash dimethyl ethyl. Okay, so these are the IUPAC names when it comes to the 4 carbon substituents. Okay, now we need to know the common names. This one is called isobutyl. Okay, it's the common names. So this is just a butyl, right? Or N-butyl. Any of those 2 are good. So when you just say butyl, we understand it's N-butyl. The next one, this is called isobutyl. Okay. This one here is called, this one is secondary butyl. And this one here is tertiary butyl. Okay. You know what? I got these 2 mixed up. So this one is the secondary. This one is the iso. Let me take that back. So this one, again, where the second carbon of the butyl is where the attachment is. Remember this as a secondary butyl. Okay. So the carbon, where the connection is connected to 2 carbons. Okay. Now this one is isobutyl. Why is this isobutyl? Because wherever the branching is, it has same. Remember, iso means same. It has same neighbors on all the sides. This carbon has same neighbors on the sides. Whereas this one, if you notice, this one, the carbon where the attachment is connected to 3 carbons, 1, 2, and 3. So that's when the common name we call that tertiary butyl. and this is abbreviated as TERT, tert butyl. Okay, so we got N-butyl, secondary butyl, isobutyl, and tert butyl. And again, these are just the common names that you guys are responsible for. Okay, all right, that's it for this video.